No. They are fat. I tell you, the fat cat is like 10 kilograms, like 20 lbs, 20 pounds. It's dog size. It's not cat anymore. So yeah, I know it's really affect their lifespan, and I want to live with them longer. So that's not really good when they are fat like that. Okay, let's start today's tutorial. I don't want to run out of time because there's a lot I want to cover today. So first thing, we will talk about absolute value. And do you decide if you were going to post these? Can you check the Quarkus one? I posted my recording last time, but I didn't post solution. When we go to in person, I cannot record, so I will post the solution. But for now, I will just post the note, like the question and the recording. Okay, good. Okay, so let's talk about absolute value. So definition of absolute value is x for x greater than or equal to 0 and negative x when x is smaller than 0. So the takeaway from here is that absolute value of x is greater than or equal to 0 for all real number x. So absolute value of 3 is 3. Absolute value of negative 3 is also 3. So absolute value is non-negative. So that's the important thing to remember here. And let's say you have a function, domain is R and codomain is R. And the function is absolute value of x. And when you graph it, it looks something like this. So they are symmetric through the y-axis. Okay, so if you look at the y value actually stands for fx, right? So you can see that the smallest value y can achieve is 0. And there is no maximum value for y on a real number as a domain of the function. I know for this week, we didn't cover function in the tutorial, but we talk about that in lecture. That's why I mentioned the word domain and codomain, because I assume that you understand it. The second thing, okay, so this one is first thing. The second thing is square root of x squared equal to x. It is always true. What do you think? It is true or false? It is true. Any other idea? False? No means false, right? It can be plus minus 8. Yeah, so if you remember last time I told you, square root of 9 equal to 3. Square root of 9 is not negative 3. You can write 9 as negative 3 squared, right? Negative 3 squared is 9. So this one, it is false. I have to use red. Okay, this one is false. Square root of negative 3 squared is actually 3. Okay, so the thing I wrote here is only true if x is non-negative. Okay, and the thing I wrote here, square root of x squared equal absolute value of x, this one is true for all real number x. Okay, because square root of a number, square root of a is always greater than or equal to 0. And you can only take square root of a if A is greater than or equal to 0. So that's what I want to recall from last tutorial. Please be careful. This one is true. This one is not true if X is a negative number. Okay, so from that, we have triangle inequality. Which is absolute value of the sum less than or equal to sum of absolute value. This one is true for all real number x, y. I will tell you why it is called triangle inequality. But if you just look at it, it doesn't have anything related to a triangle, right? But this one is a bit out of the scope for the course, but I still want to let you know. If you heard about vector, you know that you can represent this vector. Let's call this one is vector x, and this one is vector y. Then the vector x plus y is in this direction. This one is called x plus y vector. And for the x vector, absolute of x represents for length of the vector, which is the length of this line. And then absolute value of y represent the length of this vector, which is the length of this line as well. Similarly, absolute value of x plus y represents the length of this line. And you know, in a triangle, if you pick any one edge, then it's always smaller than or equal to the sum of the other edge. So if you plus this line and the length of this line together, it's always greater than or equal to the length of this line. So that's how it has a name triangle inequality. Okay, so let's move to the first question. I will let you have a vote for the first one, whether you think it is true or false. A is true and B is false. I know there is option for C, but we don't have option C here. Remember here, X is non-negative, okay? Okay, 10 more seconds if you want to join the vote. Can you show the triangle inequality for a second? Yes. This one? Okay, I will close the vote now. There are 75% chose A and 25% chose B. Can someone chose B? Let me know why. Because if you chose false, there must be a counter example, right? You can type in the chat. A is true because it is true after the triangle inequality. Okay, I forgot to talk about the equality of triangle inequality. So this one, the one here, the equality, like when they are equal to each other, this one equal to this side if and only if x times y is greater than or equal to 0, which means they are both positive or both negative. Okay, and you can use it here as x is non-negative and 4 is also non-negative. So 4 times x is a non-negative number. And you have this triangle inequality, right? And since they are both non-negative, so equality happens. So this one is true. Does it make sense? Okay. So when I ask you to vote, I actually just expect you to try plugging in number and see if there's any counterexample. I didn't expect you to come with a full proof for the question, but that's good. You know why it is true. Let's move to the second question. Remember again, xy is non-negative number. It is true or false? What part of triangle inequality do you say is out of the scope of this course? The part I explain why it's called triangle inequality, where I explain why it's related to the triangle. Because in this course, we don't cover vector, but I want to let you know why it is called triangle inequality. No, like you can use the triangle inequality in your proof, but you don't really have to know why it is called triangle. Like you can use this one. Yeah. Okay, 10 more seconds and I will close the poll. How did you fight for it? I didn't fight for it. So here, this triangle inequality is true for all x, right? Because it is true for all x and y above here. Like for all x and y real numbers, we have this triangle inequality. So instead of y, I write 4. I just put 4 in the place of y and I got this inequality. And I want to know if the equality happens. And it happens when x, y has the same side, right? And y here is 4. So I want to know if x and 4 have the x times 4 is greater than or equal to 0. And x here is a non-negative number. 4 is also a non-negative number. So if you multiply them, you got a non-negative number. So that's why the equality happens. And that's why this one is true. Does this make sense? Okay, good. So for question 2, 67 chose A and 33% chose B. I will prove for you why this one is true. So this one, just consider it as rough work because I start with something I have to prove. If you write a proof, you have to write in the reverse order, okay? I want to get rid of the absolute value, like absolute side here. So I decided to square both sides. Something like this, right? And there is something I didn't mention with you, but I think you see this in course note. So for every real number a, absolute value of a squared equal to a squared. This one is true for all a. So you can imagine this one as a. So absolute value of x plus y squared is actually x plus y squared. And you can imagine all these parts as a2, then it will be equal to absolute value of x minus absolute value of y in square. Okay. And then you expand the square. You have something like this. Okay. So I keep the left-hand side the same. I don't do any manipulation on it. But in here, we apply this rule again. And it gives us x squared plus y squared minus 2 times. Okay, there's another rule that we have to use here, which is absolute value of x times absolute value of y equal absolute value of xy. And this one is true for all real number x and y. So instead of absolute value of x times absolute value of y, I write it as absolute value of x times y. Okay. Then in here we can see that x squared on both sides, so it cancels, and you are left with 2xy greater than or equal to negative 2xy. And I divided both sides by 2, and it doesn't change the inequality direction because 2 is a positive number. So not change inequality direction. Okay. Instead, I divided both sides by 2, then I got this one. Okay. And what do I do here to make it into a fact? What do you think? Is there any way I can get rid of the absolute side? Y squared? What is dy squared? Xy squared? Okay, so we can try that. So we get something like this. And what do we do? Okay, if you want to divide, you have to think about plus xy because x and y are positive. Okay, I will come back to that, but I want to talk about the divide option here. If you want to divide by xy squared, before you divide anything, you have to think whether it is 0 because you cannot divide by 0, right? You can't have a number like this, so we don't want it. So we can consider a case when xy equals 0, then xy squared equals 0, and minus xy squared is also 0. So 0 greater than or equal to 0 is true, right? So in the case x times y equals 0, this inequality holds true. If xy different from 0, then we know xy is positive, right? Because both x and y are greater than or equal to 0. If they are not equal to 0, they have to be greater than 0, right? And in this case, xy squared is greater than 0. Then you can divide both sides of this inequality by xy squared, and it gives you 1 greater than or equal to -1. And this one is also correct. So in the case xy is different from 0, this inequality holds true. In the case xy equals 0, this one is also true. Does this make sense? Yes, okay, good. And about the option plus xy here, yeah, we are done with it. And this one is rough work. So if you write the proof, you have to write from the bottom to the top, okay? And I want to talk about the option plus xy as one student mentioned it. If you plus it in here, you cannot get rid of the absolute value, right? The goal here is to get rid of the absolute value. Okay, so I hope we are good with this. So I want to review about that because it is kind of the main topic for the course. You will see that until the final chapter as well. So there are a few common sets that you have to remember. The first one is n, which is a set of natural numbers. So it's starting from 1 and increment by 1 each time. So this one is n. And you have the set of integer, which is d. So is like n here, but it also contains 0 and negative number. Okay. So Q is a set of rational number, which means that number can be represented by the form A over B, where A is an integer and B have to be different from 0 because we don't do division by 0. Okay. I want to ask you, is 4 in Q? What do you think? Is 4 can be represented by this form? Yes, right? We can represent 4 as 4 over 1, right? Because 4 is in Z. Okay, so 4 is in Z, that's correct. But if you say 4, okay, that's correct too. Given that Z is subset of Q, okay? So every integer is also a rational number. And you also have relationship between N and Z. N is subset of Z. And you have Z is subset of Q. So you can also say N is subset of Q. And another set really common is R, which is a set of real number. Okay. So that are the 4 sets we mainly deal with in this course. Then there are what are considered rationals again. Rational is the number that can be written in the form A over B. For example, 2 over 3, 3 over 2, 1000 over 1111. Everything that can be written in this form is called rational number. Okay. Okay, and there's also the interval notation, interval. Okay. I want to ask you, is interval a set? No, no. Okay, so how do you define an interval? For example, 2, 5. All numbers from 2 until 5. So isn't it all real number such that it is greater than 2 and smaller than 5? Is a set of all real numbers that is between 2 and 5, right? So interval is indeed a set. Okay, it is a set. But on set f equal fx value, everything that looks like this is a set. Everything that can be defined using the curly bracket like this is a set. Okay, that's why these are set as well. Like set of natural number, set of real number. So interval is a set. And keep this in mind when you learn about functions. Like sometimes you will have to find the image of a function, and the image is just a set as well. Okay, so for an interval AB is a set of all x in R, so the set of all real numbers such that they are between two value A and B and not include A and B. Okay, that's why I put this as a whole because it is not included. And if you have a square bracket like this, then it will contain both A and B. So the set of all real numbers such that A less than or equal to X less than or equal to B. Let me correct this here. Okay. And let's say you have two sets A and B. Here's another topic. So you have two sets A and B. This one is A, this one is B. Then the set that I color green here, this is called A intersect B, which means if X is in A intersect B, we know X in A and X in B. So two conditions have to satisfy at one time. And if you have a set AB like this, then the part that I put the color green on is called A union B. So if X is in A union B, we know that X is in A or X is in B. Some students confuse why we don't say all X is in A intersect B. So you can say this is not wrong at all. However, if you know X is in A and B, then it implies that X is in A and X is in B, right? And we already have X in A and X in B here. So that's why it can be redundant. But if you feel comfortable, you can still say that. It's not wrong. Okay, and you have another set that I color green here. It is called a exclude B. So if X is belong to this set, then we know X is in A and X is not in B. Okay. And let's say you have universal set. It is just represent for all the value that we consider. Then the part in green is this part. It will be a complement. So if X is in a complement, we know X is not in A, right? Okay, and the last one I want to talk about is definition of A times B. So if A, sorry, let's put this on the right, because is a tuple. If a tuple is in A times B, then we know that X is in A and Y is in B. So let's say we want to draw a set n times n, right? So the first thing you have to remember is like this set will be on the x-axis and this set will be on the y-axis. So the set in position A will be drawn on the x-axis and the set on position B will be drawn on y-axis. And we will draw natural number like this. Similarly for here. And how to know what is A times B. The thing I often do is I draw a line to each point on x-axis like this. And for y-axis, I draw a horizontal line. And let's use another color. Okay. And the intersection of the two lines, all these point intersections of vertical and horizontal lines that I draw, this one is actually belong to the set A times B. Okay. Does this make sense? Okay, good. Let's move to the first question. I don't know why there's another additional page here. Okay. So the orange dot represent n times n. Yes, and as you imagine, like you make this one, how do you say that? Like you zoom out, and this one will contain more value. This part also contain more value. There will be more intersections, right? And all those orange dots represent like elements of this set. This set has infinitely many elements, and they are one of those elements. Okay, good. Let's take a vote on these. I will give you 40 seconds because I want to cover more questions. you can try to draw a Venn diagram. It is not a proof, but it kind of give you the idea which one is the correct option. Can anyone see the poll? Okay, good. Okay. Try to draw two set A and B in Venn diagram and see which part is this set and what is the relationship of it with this one. This one, if you have this, it means B is subset of A. And this one means A is subset of B. So that's the meaning of the symbol. Okay, it's almost 2 minutes, so I have to end the poll. So 71% chose C and 29% chose B. That's good. If you draw a Venn diagram like this, you can see BC or B complement in this part, right? So every part that doesn't have B is actually B complement. And I want A that is not have B complement. So the part that I want is actually this set. And this set is in B, right? I forgot to mention the definition of subset. So when you say A is subset of B, it means if X is in A, you can say that X is in B. So that's definition of subset. And based on this example, you can see that the set here is not equal to B because there are elements in B that are not in this set. So this set is like smaller. And this set, everything in this set is also in B. So it matches this definition. So this one is the correct answer. And about formal proof, you have to start with, let's take X in this set. Okay. And your goal is to conclude that X is in B. So here, this one is the subset. So we first pick any element in this set, and we try to conclude that the element is also in this set. That's how we prove any set is subset of another one. Okay, and from here we use set definition. I told you if X is in A, X could be, it means X is in A and X is not in B, right? So here we can say that X is in A and X is not in the position of B here. It is actually B complement. So we say X is not in B complement, which means X is in A and X is in B complement, which means X is in A and complement of B complement. So this one is B complement, and the complement of it is the set that like elements that is not in the red part, which means the element is in here. This one is B, right? So complement of B is actually the set B itself. And when we know X is in A and X is in B, it let us conclude that X is in B, right? It is the same as saying I like cat and I like chocolate. Then I like cat is true, right? Or you can also say I like chocolate is true. Can you explain this again? Okay. So in order to prove this set is the subset of this, I take any element from this set. And I want to prove that the element is also in B. Then I try the, you can write that, but you don't have to. It makes your life more difficult. Okay, so from this one, we use definition of set. Definition of X in A exclude B is X in A and X not in B. But in here, this one is in the position of B in the definition. So we know that X is in A and X is not in B complement. Okay, which means X is in A and X is in the complement of B complement. So you can think of complements like a negative 5, like -3, and then you negative it one more time, it just give you 3. So the complement work like that as well. So B complement is actually B. So when we have X in A and X in B is true, then we know that X in B is also true. Okay, good. Let's move to this one. I think I might go a bit over time. So when it is 4, you can leave if you want, because I want to go over at least 4 questions. Okay, just choose true or false. Again, try to draw the Venn diagram to persuade yourself that which is the answer. That's how I do before I start proving for anything. Because I need to make sure that it is true before I start proving it. The visualization makes everything a lot easier. Yeah, I agree. It's just looking at these is a bit confusing for me. It is like 50-50 now. I don't really castle this simple stuff. I like cats. Like I even want to open a cat coffee because like sometimes the foster cat or like the cat in the shelter, I think they are depressed because they have to be in the cage all the time. But I cannot bring all of them to my house. We have probably like that how yes, like if I have money, I want to open cat coffee. Like I can run coffee business and people can come and play with cat and enjoy the coffee. Okay, I have to end the poll so I can start with proving for you. So 67 chose A and 33% chose B. It's still good because there are more people choose that it is true. So in order to prove set equality, this question is confusing. Like, look at this. A, B, what is A exclude B? A exclude B this part, right? So A exclude B mean that I want something in A, but not in this one. So I want something in A that is not in the green part. So which means I want the red part. Okay, so for this Venn diagram, it seems like the statement is true, but we have to prove it formally because Venn diagram doesn't account for all possibilities. What if B is subset of A? What if A is subset of B? What if they are disjoint, right? So that's why Venn diagram doesn't count as a proof. Otherwise, everyone can get 100 easily. Okay, in order to prove A equal B, set A equals set B, we have to do two things. First step, proving A is subset of B. Second step, proving B is subset of A. Yes, I agree. Okay, so for any question asking you to prove the equality of two sets, you have to do those two steps. We will do the first step. Prove A exclude B is subset of A intersect B. As I said, in order to prove this set is subset of this one, we have to pick X belong to this set and try to draw a conclusion that X is in this set as well. Okay, so pick X in this set, and my goal is to conclude that X is in A intersect B, right? So we can use definition here. If X is in this set, just say this one is a X exclude Y, then it means X is in X and X is not in Y, right? So it looks more simple than having a bunch of stuff here. And then you can substitute instead of X, we put back the original value, which is A, and Y stand for A exclude B. So we put it in. We want to prove that X is in A and B, which means we want to prove that. So before this, we would have something like X is in A and X is in B, right? So here we have X is in A. The only thing we have to do left is proving X is in B. But it seems difficult to get it from this one. So I tell you, there are only two possibilities. X is not in B or X is in B, right? There are only two possibilities for X. So like if you have a universal set, so X is either in here or X is either out here. It cannot be anywhere else. So we assume that if X is not in B, and we know X is in A, we know it from here, right? We know that X is in A and X is not in this set, and we assume that X is not in B, combined with what we know that is X is in A, it gives us X is in A exclude B, right? Because it's the definition. X in A and X not in B implies X is in A exclude B, and this one is impossible because we already have X is not in A exclude B here. Therefore, X has to be in B, right? Does this make sense? And since we know that X is in B, and we know X is in A, it means X is in A and X is in B, which means X is in A intersect B. Is there any questions? How about everyone else? I get it. Good. Okay. So we proved the first side. We proved that. Why do I put a page here? Okay. So we proved that this one is the subset of this, but we actually want to prove the equality. So we have to prove the other way around as well. So second step, we want to prove A intersect B is the subset of this one. So same process, we pick X from A intersect B and use the set definition. It is X is in A and X is in B, which means X cannot be in A, X could be, right? Because X could be means that X is not in B, but then X is in B here. So that's why we can conclude to this one. And we know X is in A. So from these two, we can say that X is in A, X could be. Okay, so we starting from picking X in this set. We arrive at X is in this set. Therefore, A intersect B is a subset of this. Does this make sense? Okay, good. And I think this is the last question I want to cover for you. Question 5 is the same kind of question. So it asks us to sketch A times A X could be. So we can draw like this. Y and X. We want to draw A times A, right? So A is on the x-axis and A is also on the y-axis. So if we draw it, we have -1 up to 1. And this one is the interval and include those two, right? And it contains all real numbers, which means it contains every point in this line, right? Which means if you want to draw a vertical line, it would be like this. Because we have to cover all points in that interval, right? And if you draw a horizontal line, it would also look like this. And the intersection, do you see that? Like the intersection is actually a square, right? I don't know if you get it because the drawing seems terrible. Can we just color in a square during a test? Yes. So we just expect you to color a square, not drawing all those ugly things like me. So this one is A times A. Okay, so everything inside the square, everything inside the square is A times A. This part is A times A. Because we just care about the intersection. Okay, and we want to exclude B. So B here, I tell you, X minus, not X minus Y, X minus N squared plus Y minus N squared equal R squared. This is the equation of a circle. Center at MN with radius equal to R. Okay. And then if you think about X squared plus y squared equal 1. It is a circle center at 0, 0 with radius equal to 1 because 1 is actually 1 square. And this one is actually x minus 0, everything squared. This one is y minus 0, everything squared. So 0, 0 is the center. And this one, square root is a radius. But square root of 1 is just 1. That's why radius here is 1. And center here is 0, 0. So if you draw it like this, can you see it here? Okay. And make it look so ugly. Okay. So this equation here, x squared plus y squared equal 1 is actually this circle. But here we want that less than or equal to 1 because, sorry, so if it is equal to 1, it means all points on the green line here, the distance from it to 0, 0 is 1. But we want something distance less than or equal to 1. So everything inside this circle is actually nearer to 0 than nearer to the origin than anything on the green line, right? Everything in here is nearer, like the distance is smaller. So when it say less than or equal to 1, it actually means everything inside the circle. So this one is how the set B look like. And we want everything in the set A, but not in the set B, which means I want everything inside this, including the border, okay? Because here it is a square bracket. So I want anything inside here, but is not having green color. So if I redraw it from the graph, if I have something like this, -1, 1, -1, and 1, I want everything including the border. But I don't want anything having green color. So we can represent something not included by the dotted one. Instead of solid line, we just have dotted line. And remember here, we don't want these points. Ew, why did it happen? Like this point, 4 point here, I don't want because it is indeed green. If you look at this, they are green. I don't want green. So just the corner, yes. So this one, this one, this one, this one, and everything inside here as well. Because if you remember, I said everything inside this square is A, right? But everything have green color is actually B, and I want everything in A, so everything inside it, but not in B, so not having green color. That's why it's translated to this graph here. Does this make sense? Okay, good. I will stop the recording.